Hello, everyone. I am Anjali Gola, a software engineer at Intel in the Intel System Studio team and the Arduino Create team. So I'm going to share my screen now. So today's presentation is about cloud connectors. And before we jump into learning about how to use cloud connectors, I think it's really important for us to understand what are cloud connectors. So, in the IoT world, when we say cloud connectors, we mean the technology that connects an edge or a cloud device, an edge or a gateway device to the cloud. So, I would be talking about web services that form the technology which connects a device with the cloud. And the device can be a edge device, which is basically terminal devices that are not, doing very intensive computation, or light platform devices. And then how do we connect it to the cloud? So since we are all in IoT DevFest, I will assume that we have a basic understanding of what IoT is. So IoT as this huge network of devices that are constantly collecting data. And to do smart things with the huge amount of data that we need some smart and advanced tools that enable us to implement the ideas that we have. But doing these smart and advanced things with heavy tools comes with a cost. The cost can be in terms of computation power. It can be in terms of computation time. It can be in terms of data storage space. So these 3, 4 things are expensive, and we do not have a lot to spare. So what we do is we try to organize it out. We remove all of this from the edge and put it on the cloud. So now you will have a edge device, which is very lightweight, like the Arduino 101. And then all these costly things of computation power, computation time, data storage space, they are pushed onto the cloud. For this, we utilize cloud service providers to connect the lightweight devices on the edge with the powerful devices that are our cloud servers. So why exactly do we like these cloud service platforms? So because these platforms come with an inbuilt set of tools, they're very good for quick development. So as a professor who is trying to teach students, or as a a hobbyist who's trying to learn a new technology, if you want something which has all the tools set up, then the cloud service platform provide you that entire like I would say a toolkit of being able to develop end to end for your application. So why reinvent the wheel when these Sika cloud service providers have already done it for us? So we can use these cloud service providers not only to transfer data, but also to operate on it, to understand the data, to make sense out of the huge amount of data that we have, to get some information that is meaningful and that can be used as an input into further operations. So this leads to this speed of development, and the ease of development leads to obviously more innovation by giving developers the time and energy to focus on the new thing that they're trying to do instead of just trying to put together old stuff. Then we talk. Then another criteria when choosing a cloud service platform can be the speed of data. How fast do you need the data to be transferred? In some cases, you don't really care about the speed. Maybe if you're collecting content from a edge device once per day, then speed does not matter. It doesn't matter whether you send it at 10 a.m. or at 11 a.m. as long as it gets there. But if you have an edge device that's sending data by the second, then speed of data and how much that speed is going to cost will be an important factor. While this data is being collected on the edge or being stored in the cloud or is in transition, how do we ensure that the data is safe and it's not being touched by something malicious, it's not being lost, and It's consistent with all the other parameters maybe being tightly controlled. Cloud service providers provide cloud service providers along with the industry protocols that have developed over time help us implement security of data. And as I said earlier, all of these three things take cost into consideration. And since we moved all the costly things to the cloud, there is a certain factor that comes into consideration. But the good thing is that if we were to compare the cost of having all this computational power on the edge devices instead of the cloud, it would work out way more expensive. So even though there is a cost of operation with this setup, it is lower than what you would have had, let's say, 10 or 15 years ago. And with how the industry is evolving now, I think this cost of operation will go lower. A lot of times, the cost of operation can also be subsidized by planning well about the application's architect. Like you can talk about things like caching. We can consider things like averaging out data points and use all of that to minimize how much data transfer is taking place, and uh, that will help control or bring down the cost of operation. But in certain cases, the cost is totally worth it, especially when it comes down to reliability of the platform and making sure that you're not the system is not crapping out on customers. So that's where the cost becomes really worth spending the money on. A lot of us might be, beginners to the IoT industry, and even if we have worked before in the IoT industry, when you start a new project, it goes from this prototyping stage, and then kind of developing a proof of concept, and then moving on to scaling it to be of production quality. So the right cloud service provider provides the resources to expand the proof of concept that you might have developed into a larger product that can be scaled according to customer needs. It can be scaled according to production needs. Production needs more quality control. Production needs more security. So that scalability becomes a very important factor when we talk of commercializing any IoT product. Now, out of these five things, what is most important to you as a developer, or maybe as a program manager, or as a project manager? What is most important would depend on what is the context of the application you are developing. It will depend on whether your customers expect a very tightly controlled, secure platform. I'm assuming that this would be a yes in most of the cases. It would depend on who you are working with, what is the platform or the application model. So a lot of factors come into play. It's kind of like going to the supermarket and shopping around for what cloud service would be my best choice for a particular scenario. When we go to shop around, these are some of the possible options that you will see. Amazon Web Services, Microsoft Azure are probably the most used as of today, and I would say I would be covering them in uh, going forward. And others are IBM Watson, Google Cloud, GE Predix, Oracle, Salesforce, Cisco, Ali. I know there are more like Ali Cloud. Uh, I think Citrix also has something. So there are a lot out there. Again, as I said, there are many factors that come into play when deciding which cloud service provider to use. I will be focusing on AWS and Azure. And so now that we have some insight into what cloud service providers are, let's go into how we are going to use these cloud service providers in an application. So the first step, I think, would be choosing your development environment. And if you are a beginner into the IoT space, I saw some questions yesterday on the portal about, what tools should I be using? Where do I even get started? What to, what, which editor do I need? Those kind of questions. So here on the screen, I have two editors. One is the Intel System Studio, which released the 2018 beta a couple of months ago. You can use the links on the PowerPoint to access these, and the Arduino Create platform. Both have their own I would say use cases, and so it would come down to kind of testing them out and choosing which one works best for your use. If using an integrated development environment is not your style, and you want to just stick to using the shell and your favorite editor, that's absolutely okay too. Cloud service providers in general work like they're like a standalone library, and some of them come with SDK. Like I know AWS comes with with the AWS IoT SDK. So that's absolutely your choice. So, but what using this ID does is it takes care of some of the development steps. So I know that Intel System Studio and Arduino Create both come with AWS and Azure support inbuilt. So there are samples. There are through the package manager, you can get the right packages you need. So it takes care of some of the steps for you and prevents you from getting lost, especially if you're doing this for the first time. Quick disclaimer, I am a developer on both these products, so I feel obviously very passionate about them. And it's absolutely your choice on what IDE to use. Intel System Studio is a Eclipse-based desktop IDE. So if you have worked with Eclipse, it will be your obvious choice. Arduino Create, on the other hand, is a web-based IDE, and it's really recommended for rapid prototyping. So I'll go through AWS on Intel System Studio, and before that, I'll do Azure on Arduino Create. So before we dive into kind of seeing the demo, I'll just do a quick explanation of the PubSub model. In the IoT field, the MQTT protocol is a very standard protocol, which basically governs how you're going to interact, it basically provides the rules of the communication infrastructure that an IoT cloud service platform would provide you. So this is called the PubSub model, which is what is happening here is we have, so all these orange things are devices here. So we have and they're all connected over a network. There is a device that's the publisher. So in an IoT application, you can consider this as a device which is lying somewhere in a field, and it's a sensor. Maybe it's collecting humidity or temperature or something. When this then the infrastructure defines topics. Topic can be, let's say, topic A is humidity control and topic B is temperature control. Subscriber 1 and subscriber 2 are devices or control instruments that only care about humidity. They don't care what the temperature is. So maybe they are, this is an air conditioned room, and they're kind of doing a feedback to control the humidity and temperature of the room. So on the other hand, topic B being temperature, subscriber 2 and subscriber 3 are the only ones who care about it. So what this protocol does is it avoids sending unnecessary information about topic B, which is temperature, to the humidity controllers, and vice versa, avoids sending humidity information to the temperature controllers. So this is a very basic PubSub model that I thought I'll revise for the sake of who are not familiar with this. So the publisher, whenever it publishes, let's say it changes, humidity is changed to 64 now. So the message will only go to topic A and only be sent to subscriber 1 and 2 and not to 3. So when we go into this sample, if you can, please go ahead and use the links to access the sample app. It is being used on Arduino Create, and I think I forgot the Create URL, so I'm going to paste that in chat right now. So every application that you do for with cloud connectors will need you to have some kind of credentials or setup that is needed to be done on that cloud service provider's platform. So for Azure, this is the URL, and what we need to obtain from this URL is kind of set up an IoT hub and get a connection string. So I will demo that now. I'm going to try to demo as much as I can live. Obviously, Murphy's Law might step in, and if I'm not able to get something working, then we'll jump to screenshots. So I am logged into my Azure portal. I will now create a IoT Hub. By the way, if you want to like follow all of these steps, the first link I posted about the samples has all the steps very clearly marked, so you can follow those later and maybe kind of just see what I'm doing right now. So here is if you don't see the basically the IoT Hub, the Azure also has a keyword search. So I am going to go ahead and create an online IoT Hub. I will name it um, DevFest demo. And then I need to provide a resource group. Resource group is resources are basically I would like resource group is basically a group of devices or virtual devices rather that will follow the same sharing policy and the same access rights. So right now we're not telling the portal, oh, we have this and this device. We are just saying, let's create a blanket resource group uh, to which we can apply a policy, and that can be used later by any of our devices. Think of it like when you have a laptop, you have roles or groups, user groups in it. So it's pretty much like a device group. So here we can see in the notification center that deployment is in progress for that resource group. This has taken sometimes from 30 seconds to 4 minutes for me. So while that gets done, I'll show you in something about the Arduino Create IDE. This is the editor screen for create.arduino.cc. It has the web editor is what I had open earlier. Getting started helps you connect your IoT device to the cloud. And the way it works is that everything is all of this, my code is all on the cloud. And when I try to verify and I upload, it sends this code to the cloud. The cloud then sends it to my device. And then this project, or as they call in Arduino Create terms, a sketch would run on the device. So you can already see that I have a upsquared GroveKit board connected to this IDE. The board is sitting at my cube. So this is a really good convenience here that I'm sitting far away from where the board physically is, and I'm still able to connect. And this is something we don't get if we are connecting over USB or doing a hardwired connection. So Arduino Create comes with the Azure and AWS support inbuilt. So I scrolled to libraries, and there I find AWS IoT Device SDK already included, and Azure IoT Device SDK also included. So if you were to go to AWS's official repository, they have a device SDK, and this is the one that I am basing my tutorial on. And this is the one that's in Arduino Create is basically a fork of that one, slightly customized to work in the cloud environment. So looking at the Azure ones, it comes with the basically a pub/sub model already included. If you let's say I already have this Blink example, if I wanted to, sorry about those trailings, if I wanted to include this immediately or in any existing sketch, then I just have to press include, and this header gets added. When this is compiled on the cloud, the SDK is automatically included. So it's as simple as adding this line to your existing project. If you want to use the sample, you just have to go here, click, it loads the sample, which is basically using all of the pub/subs setup. So this sample has a secret tab here, and this is basically Arduino Create's way of giving you a UI where you can provide a connection string. And connection string is something you can think of in term as authentication string. So let's see if our Azure platform is ready or not. So deployment is still in progress. We'll give it some more time. Once that deployment happens, what I will get from there is a string that says that authenticates my device to the hub. And Azure provides a very nice utility called the Device Explorer. I think I posted the link on chat. Yes. And if you're on Windows, it's like a Windows app. If you're on Linux, it's a command line app, command line program. And what this it's like a a fake device. Like consider this desktop tool as a fake device where you can try to connect to the hub or try to uh, publish to the hub or listen to it. So what my demo does is basically uses this app that we have on Arduino Create to publish to a topic and then uses the Device Explorer to listen to that topic. I will, as I said earlier, I'll try to demo as much as I can live, but I expect that towards the end, I'll get blocked because I'm on a corporate network, and a lot of corporate networks block the MQTT port. So even if you are developing in an office environment, you might want to uh, pay attention to any errors that you face due to port blocking. So looks like my deployment is done. So I'll go here to all resources and I can see the DevFest demo resource has been created. So this dashboard is really informative. Maybe in the beginning it can seem a bit overwhelming, but this graph here, it's a very short insight into what usage this hub that I have just created is having. And obviously it's at 0 messages right now and 0 devices. You might also want to pay attention to the 400K it says here, which is basically, I'm guessing it's maximum capacity with the current pricing plan that I am on. So what we are going to check now is what's the shared access policy. So this it comes with a group of 5 default policy. The first one, IoT Hub owner, is created, and it basically is kind of like it's good to use when you're developing or prototyping, but I would not say use it when deploying, because it's like a admin access, so it gives you all read and write accesses. So what we are going to take from here is the primary connection string, and I'm going to put that primary connection string here in the Device Explorer. I will click on update. So now my Device Explorer knows about the hub. Then I'm going to go to management and create a new device here. So if you're new to IoT development, we'll try to wrap or understand about how device shadows or virtual devices work with cloud service platforms. A lot of, actually, I think almost all of cloud service providers assume or want that you have a virtual representation of your hardware device. So when I'm creating a device here, what it means is that I'm creating a virtual device to which I'm giving these authentication strings, and then I'll connect this authentication string to my hardware device. So I created this device. Now this device has been added to the hub. Now what we want to do is connect this device to the application I have on Arduino Create. So I'm going to right click on that and copy the connection string for this device. Then I'm going to go to Arduino Create, go to the secret tab and enter this connection string here. When I move this, so for moving a example to your sketchbook, which is basically a workspace, one just needs to save a copy of that sketch. So that's what I'm doing here. And then I can see that that particular sketch has been moved to my sketchbook. So it has this connection string. The advantage of this connect secret tab is, let's say I share this sketch with someone, and that's really this is another thing I really like about the Arduino Create environment, that I can just copy this link and send it to all of you, and you will be able to open the sketch, but you will not get access to the secret key that I pasted in my sketch. So once I have the secret key pasted, all I need to do is compile and upload this to the cloud. When the sketch runs on the device, it will upload data to Azure, and here in this in the device explorer, there is a way to monitor. The data tab gives you a way to monitor the device that you just created. So let's see if I can start that. This is happening because, again, as I said, I'm on the I'm on a corporate network, and that protocol would not work. So by just putting the device ID here, let's see if we can do at least some more. Yes. So now I can start to monitor the first device. So this is so it's in the status of receiving events, and if my app were running on the device, I would be seeing those. So I have some screenshot here, which is basically showing side by side a publish happening of a device that is running this application. Arduino Create provides a serial monitor, which is really handy for seeing all of the logs. So here we can see somewhere in between the publish happening, and then on the right-hand side, the device explorer is kind of getting the data that the app is publishing. In the real world, you would not have the device explorer. You would have another device, or maybe a control device, or you could possibly be sending this somewhere on the Azure portal and using another service to do something based on the data you are receiving. Like for this one, a very basic use case would be like that temperature alert right now is false, but if it turns true, then we ask the Azure portal to do something special. So that was how to use Azure on Arduino Create. Next, we would be talking about how to use Amazon Web Services on Intel System Studio. One thing I do want to point out is both everything from about the setup remains the same irrespective of which ID you are using. So what I explained right now about Azure can also be used with the System Studio setup. And similarly, the AWS setup can be used with the System Studio setup. Oh, sorry, Arduino Create setup. The difference where you will see is that both AWS and Azure have different ways of connecting or things that they need. So if you look at point number 4 here, this AWS needs client ID. It needs a thing name. Thing is basically AWS's way of calling your virtual devices, and it needs a root certificate on the device. It needs a device certificate. All of these things are really important for us developing a secure application. Uh, it's just different cloud service providers do it in different ways. So I've posted the links for the app that we would be using for this. Alternatively, you can also use the Arduino Create application. And the subscriber in this case, I'm sorry, there is a typo in the presentation. It's not the device explorer, but it's the Amazon console. So I see we have about 8 minutes, so I am pretty sure I'll not be able to get to a demo, but let's take a quick look at the Amazon portal if we can. So this is the landing page for Amazon Web Services, and if you have used it for other services, you would be familiar with that. A lot of developers use EC2 if you're developing for the backend. I searched for IoT there and got to this dashboard. So there are lots of setup steps that I will not be going into today, but they are very well documented on both the sample links that I've provided. So all these steps include, creating a virtual device, then creating policies for it, getting the endpoint that you would publish to, setting up the security policy, and a bunch of other things. The certificate part is what I would say differentiates AWS and Azure the most. What AWS wants is that you put a root device certificates on the actual hardware device. And in some cases, this can be a problem if you don't have a way to SSH into the device, or if you don't have very good connectivity to the device. I know this is a problem for me when I'm working behind a proxy environment. So what Arduino Create provides as an advantage over this is that, again, it has the secret tab. And instead of providing the string through the providing the certificates, you can also provide the values of the root certificate, the client private key, through this secret tab. Again, this is not really something I would recommend for a production. Actually, I'll strongly recommend against it for production. And even if you're using this for rough development or prototyping, take care not to publish your root certificate or any sensitive information on this, because this is indeed going to the Arduino Create Cloud. So coming back to the AWS portal, I do not have any devices connected recently, so we do not see any data. But if I had the app running, then the dashboard would have been something like this. So it's showing me how many, what is my activity over time, how many devices I have connected at a certain time. And we can see here it says successful connections as 41. So the screenshot is from a time when I was using it heavily. This is really useful when you are setting up this graph about connect, ping, publish, or subscribe is really useful when you're trying to make sure everything is working or not. And just like Azure, AWS also provides something which you can use in testing. It's a widget on their website. It's called the test widget, and what it does is basically gives you a way to create another virtual device and see if any topics are being published by this device here on listed on the top to this topic. If any message comes, it will be shown here. I have a screenshot of that here. So here you can see my device, I'm connected as thing01, which is the device that was publishing at that time. And I can see that all of these messages were published to this is the topic here, SDK/test/CPP. And there are, I think, 3, 4, 5, and 1 or 2 are probably below the image, and those are being published. So that is all. One last thing I would say is, and I unfortunately don't have screenshots for this, but when you create a new project with Intel System Studio, if you have chosen a PubSub sample, right at the project creation stage, it will ask you for the endpoint and the certificate file names. So this is the kind of extra support that the IDE already comes with. And if you have already pushed the file into a known folder on your target system, then it's easy to just provide that file name, and the value will be absorbed by the sample automatically. So in the if you were to go to the AWS SDK in this original sample, the value is taken from a sample config JSON file, and that model doesn't always work for everyone. So be careful though that anytime you're, in fact, that's like standard practice. Anytime you're using keys or root certificate, be careful where you're putting them. I did have one very interesting experience with AWS where I had uploaded something accidentally in a Git repo, and I'm not sure how they scan GitHub or whatever, but they sent me an email saying your key is online and you need to remove it from there. So I was very impressed that they were tracking, kind of creeped out, but also impressed that because it prevented from someone from accessing my master key. So that's all for my talk. Now I will be moving on to questions. Yes, Shubham, your comment about using Python as a programming language and hosting it on a cloud is very helpful. If a developer is familiar with Python, I'll say using that is for quick setup is very good. And I have noticed that for AWS and Azure, I'm not sure actually about Python on Azure, but AWS Python setup works really well. Someone asked whether it sounds like in the scope of collecting data and sending to the cloud service, IoT is very similar to non-IoT. Would you agree? The MQTT send. Yes, and then they follow up with the comment that sending to AWS is same. AWS IoT just provides center data analysis towards support sensors, etc. That is very true. And they also provide the extra support for the certificate part. I think there is slight difference there because the thing to understand here is with regular applications, you have a better chance at doing revisions, doing firmware updates, doing frequent code uploads. But if you're talking about a IoT application that's out there in the deployed in the field, then you have to worry again about the cost factor of what it takes to make any changes on the field. The next question is that do we have a comparison of Microsoft Azure and AWS in various aspects related to IoT devices? This is probably my favorite question of today because I talked a lot about what to how to choose something, but which ones are the what would be the exact criteria? That's not, we don't have a lot uh, of content on that. So the reason we don't have a lot of content is because they are changing by the day. I have experienced that I create a health document, and 6 weeks later, when I'm reviewing it, I'm seeing that the steps have changed or they have introduced something now. I just posted a chat link for where which talks about what are the 10 top ones and what are the pros and cons. Well, I won't really endorse any of those. I mean, just because don't want to be partial, but Azure and AWS do come out as great, valuable ones, and then Google Cloud is another one. To do an exact comparison, I think just searching for articles would be your best bet for now. Yes, Shubham comments that IoT is not about to send or receive data from the cloud, right? So yes, IoT is not just about sending or receiving data from the cloud. That would just be cloud. We have done that since a long time. We have been doing that for web apps and desktop apps. But at least for this talk, the topic was how to do that with IoT devices. Because what we have to understand is that there is a difference in how much you can send when you're talking about IoT. Because IoT devices do not, what I talked in the beginning of this presentation, they do not have the same kind of data bandwidth. They do not have the storage space that traditional devices used to have. So there are it basically comes down to making it very lightweight, making it reliable, and making it very quick. I'm sorry, I'm not able to pronounce your name correctly, but someone comments that through this conference, I'm seeing a likely strong blanket solution would be having devices such as Arduino reporting sensors to a local edge device so it can be stable. The edge device would sift through all the sensor data and decide what actually goes to the cloud, and the edge device could more easily be upgraded. Is that a good train of thought? It is a perfectly good train of thought, and there is actually a term for that. So the local edge device, we are starting to call that a gateway. So imagine 5 edge devices, like truly edge, at the very end, like the Arduino, and all of them connect to a gateway device, which has the ability to sift through all the sensor data and then, as you said, decide what goes on the cloud. And these gateways are more powerful. So if you just Google, Intel gateway solutions, you'll see results like Intel NOC, there is the Dell Wise, and then um, these days a lot of powerful edge devices like Intel Joule or Intel Upsquare board. They are so powerful that they can also be used as a gateway. So and a gateway it's basically nothing. It's just like a small computer that's been modified to work more in be more IoT friendly. So yes, having that kind of setup is what the new trend are. So Shubham asks that if since AWS and Azure are heavy, if we just want to send or receive data from cloud to microcontroller or vice versa, why don't we build our own IoT platform? So I'm not familiar with ThinkSpeak, but there are, I think AWS and Azure are actually not that heavy. I have tried them on low scale ones. If you try to take the entire SDK and build that, yes, that will be big, but you need only the SDK only for development. One does not need it for rest, just actually deploying an application. And uh, Intel makes apt-get packages for AWS. If you do a quick Google of Launchpad PPA AWS packages, you'll be able to find those. So they're pretty lightweight. But one can take MQTT libraries, like the Paho library, and they have very lightweight clients, and just use that to connect. Alternatively, you also use HTTP, which a lot of devices already come configured with, so you can just send data using that. It depends a lot what your application is. If you don't care about security protocol, or it's not a huge amount of data you're setting, and it's just one device that you're receiving the data from, then sure, choosing your own IoT platform would work very well. Someone just yeah, of course. There's also another link posted in the chat talking of gateway solutions. Yeah, so these are really powerful devices that can, I've seen them run complicated SDKs like face recognition and OpenCV, and they are doing more than just sending data from one to the other, and doing really things which used to be only desktop uh, viewed as desktop processes only in the past. So, MS Sabarinath has posted a comment on chat talking about their research on a lot of IoT context. So, and they say, I am seeking your advice regarding IoT patterns. There are a lot of barriers I'm feeling again and again. I've done successful prototyping projects, but when it comes to real-time professional projects, I'm not getting a proper shape to design, which I assume is architect. My question is there any standard operating procedure for designing IoT to transfer traditional into smart in each and every sectors? How can Intel products be applied? So the other tool that I've been talking about, Intel System Studio, is actually a very advanced tool that you can use for giving a more production level quality to your project. It comes with debugging. It comes with analyzing power analysis and all different kind of things. So do check that out. But you are right, it's a evolving space. So it's not as evolved as some other technologies are, where everything is ready. So there are barriers, but I think conferences like these can try to reduce some of those barriers. Please do check out Intel System Studio. Santosh asks, what are the security challenges we see in connecting IoT devices over cloud on Microsoft or AWS? What are the important watch points to consider? So this a very great question. Thank you, Santosh. So the biggest, I think a lot of times we worry about how do we keep the hardware secure, right? And if it's out there in the field, anybody can grab it and steal it. But if we develop the application in such a way that even if that happens, we can, kind of shut down the device the way we do with phones, remote turn off, those kind of things, then we can take off care of security of remote IoT devices. When you say what are the most important watch points to consider, I would say it is how you deploy the certificates. And to make sure, I see around even myself here that a lot of devices get shared. One developer works on it, then it gets shared with someone else. And if the care is not taken to make sure that there are no keys transferred or certificates left on the device, that can be a problem. So another challenge is with uh, tools that do not enable tools that do not provide the extra support for uh, understanding security. So I guess I'm not phrasing it correctly. Give me 30 seconds here. So the tools that one is using for production should provide the developer all the information they need to make sure their devices are secure or not. And I see out there a lot of tools don't do this, including some we talked about earlier. So some of them do it really well. I think Intel System Studio does it really well if you want to check that out. But the important watch points would be definitely making sure there is an authentication method set up, making sure one is not using blanket policies. Like in my demo, I was using the IoT Hub owner policy, right? Which is kind of like giving all my devices admin policy. If someone were to hack into that device, they can access the hub and then write to the hub, which can eventually access other devices. So that kind of safety is really needed. So comment and chat says that they do want to echo that problem, that until this conference, they didn't know what resources are out there for advanced development. That's very good feedback. And as a developer on one of such products team, I would take that feedback back to my team and see what we can do about that. Thank you.